Okay, these are quick and easy. And I'm actually think I'm going to type these because anytime you do some operation and you get the exact same number at the end, it maintains its identity as a number, right? It doesn't change its identity. In this case, negative 2.1 is still negative 2.1 after applying the operation. So we call that the identity property. And then of what operation did we do? We did of multiplication, identity property of multiplication, because we multiplied it in such a way that it didn't change its value. Okay? Now, likewise, what did we do with x so that it continued to be worth x? Okay? What did we do to it? Well, all we did to it was add 0. So since we added 0, and that doesn't change its identity, this is also an identity property. But of what? What operation did we do? Well, this was of addition. Okay? We can add 0 to something and it doesn't change its value. So that's also an identity property. Okay? I hear kids throwing out these ideas. They have a little kind of struggle with the understanding of these concepts, what the words mean in relation to what they're seeing, but it's all pretty straightforward, I think. Once you get your mind around it, you're like, oh, of course, that's what it's called. Like this next one. Okay, this next one says, we're not changing the order. That would be the commutative property, okay? When you commute or move back and forth, like commuters do, moving back and forth to work. Okay, commuting on the bus or something. These aren't changing the order. We've got a 7 and a 4 and a 4, just like we've got a 7 and a 4 and a 4. What's changing here is the grouping of it. Okay, these two 4s are hanging out together. They're associates of each other. They're associating, and they're going to be associated and done first. Versus on the right-hand side, these are associating together or hanging out together, and those are the ones that get done first. Okay, putting parentheses around them changes which gets done first by associating some numbers together. So we call that the associative property. The associative property of, and what does it work for? It works for the operations of addition and multiplication. In this particular case, it's addition. Okay, we can't change the order in division. We can't change the order in subtraction. We'll get different answers. Okay, but we can. I'm sorry, I said change the order, but what I'm saying is changing the grouping or the associative ability of these things to group them first and still get the same answer. We're not allowed to do that in division or subtraction because the numbers won't work out the same. But with addition or multiplication, you can. Okay, and finally, sorry for the confusion there. And finally, number 20, what are we doing here? We're just changing the order. We're changing the position. We're moving things around. Okay, and when you move the position of things, we call that commuting. Okay, commutative property, meaning we're allowed to move the order of things and we get the same answer. In what particular operations? Well, we can do that in addition and we can do it in multiplication, but what's happening here? What's happening here is multiplication. Okay? Yep. And why does that work? Well, because if we're doing 2 groups of 3, that's the same as 3 groups of 2. There's the same amount of stuff in there being grouped together. So legal move, you're allowed to move the order of the multiplicands, they call them, the numbers that are multiplied together, and you'll get the same product.